In this video, we will explore how the crankshaft position sensor works. We will explain its internal construction and how it operates together with the camshaft position sensor. This is the crankshaft position sensor, or CKP. This sensor allows the engine speed and the crankshaft's angular position to be determined. This information is sent to the ECU. The ECU uses it to decide when to inject fuel and when to generate the spark in each cylinder. In a vehicle, this sensor is located very close to a wheel attached to the crankshaft, called the reluctor wheel. The reluctor wheel is made up of a series of evenly spaced teeth. Each tooth represents a small rotation of the engine. The CKP sensor generates an electrical pulse each time a tooth passes in front of it. We will see how it does this later. As the wheel rotates, the teeth pass by the sensor, generating a continuous sequence of electrical pulses. Thanks to this signal, the ECU can calculate the engine speed by measuring the time between each pulse. Now we know how the ECU determines engine speed. But how does it determine the crankshaft angle? To answer this question, let's first take a look at the internal construction of a CKP sensor. Inside it, there is a permanent magnet and a coil. Inside the coil, there is an iron core. The magnet generates a constant magnetic field in the front area of the sensor. When a metal tooth approaches this area, the magnetic field is altered. This variation in the field induces an electrical signal in the coil. When the tooth moves away, the field changes again, generating another signal. The core concentrates the magnetic field, allowing the coil to generate a clear electrical signal. In this way, the passage of each tooth in front of the sensor is translated into an electrical pulse. However, this design presents a fundamental problem. Can you guess what it is? If all the teeth were identical, the signal would be completely repetitive. The ECU would know the engine speed, but it would have no reference to determine the exact position within the rotation. To solve this, one or more teeth are removed from the reluctor wheel, creating a larger gap between pulses. When this gap passes in front of the sensor, the ECU detects a longer than normal interruption in the signal. This interruption indicates a specific and unique point in the crankshaft's rotation, which the ECU can recognize unambiguously. From that point, the ECU begins to count the pulses generated by the teeth, thereby reconstructing the crankshaft's angular position at every moment. Up to this point, the ECU can accurately determine the crankshaft's angular position and rotational speed. However, in a four-stroke engine, each piston reaches top dead center twice during each cycle. With only the crankshaft sensor, The ECU cannot distinguish whether that top dead center corresponds to the compression stroke or the exhaust stroke. The signal is identical in both rotations. To solve this problem, the camshaft position sensor, or CMP, is used. Like the CKP, it generates a signal from the passage of metallic elements in front of the sensor. Its function is to identify the camshaft position and work together with the CKP so the ECUs can synchronize fuel injection and ignition. Let's recap and see how everything works together. First, the ECU detects the reference point on the reluctor wheel and at the same time calculates the engine speed from the pulse frequency. Then it begins counting the crankshaft pulses to determine its angular position. Finally, it uses the camshaft information to identify the correct engine cycle and synchronize fuel injection and ignition. With this, we conclude the operation of the crankshaft position sensor.